This presentation introduces the concepts and equipment used in underbalanced drilling operations. The key differences between underbalanced drilling and conventional overbalanced drilling are at both the conceptual and the technical level. At the conceptual level, the subsurface drilling conditions need to be investigated further. The rotating drill bit cuts away rock to deepen the well. The drilled cuttings are lifted to the surface by the circulating drilling fluid. In conventional overbalanced drilling operations, the hydrostatic pressure exerted by the drilling fluid in the well is designed to exceed the pressure of the hydrocarbon fluids in the reservoir. Since the pressure in the hole is higher than the pressure in the rock, fluid and fines are lost to the formation. These losses cause damage to the near wellbore area, resulting in reduced production. Experience shows that even a short exposure to overbalanced conditions can severely impair the productivity of a well. In underbalanced drilling operations, the hydrostatic head of the drilling fluid is designed to be less than the reservoir pressure. This means that there's a continuous flow of hydrocarbons into the well during the drilling process. Under these conditions, no near wellbore damage occurs and the well's ultimate production is not impaired. The prevention of wellbore damage has several advantages. Near wellbore damage prevention is just one of the benefits of underbalanced drilling. Another benefit of underbalanced drilling is the reduction of drilling problems, such as differential sticking and drilling fluid losses. Producing the well while drilling increases reservoir knowledge. With this knowledge, wells can be steered into more productive zones. Reservoir pressure and depth determine the required density of the drilling fluid system. Unlike conventional drilling, which is limited to simple fluid systems, underbalanced drilling uses a variety of fluids to control bottom hole pressure. At the high end of the density scale, light fluids such as water, synthetic base oil, natural crude or diesel form the drilling fluid. To achieve lower bottom hole pressures, a two-phase flow system can be employed. This system consists of a light fluid aerated with a gas, such as nitrogen or natural gas. Foam systems generally consist of water and a surfactant. At the low end of the scale, mist or air-based systems can be employed. Each of these fluid systems requires a different surface setup. In what follows, the commonly used two-phase flow system is shown as an example to illustrate the technical differences between underbalanced and conventional overbalanced drilling. A two-phase flow system setup consists of the following elements. The light drilling fluid is stored in the rig's mud tank system and is pumped to the well by the rig fluid pumps. Lifting gas, in this example nitrogen, is injected into the fluid stream. Depending on the quantity of nitrogen needed, the source of the gas can be cryogenic tanks or a membrane unit that separates nitrogen from the air. The two-phase fluid stream is injected into the drill string using the conventional rig systems. The two-phase fluid exits the bit at the bottom of the hole, carrying drill cuttings up the annulus. Since the hole is drilled underbalanced, reservoir fluids such as oil or gas are produced from the reservoir and mingle with the two-phase fluid moving up the annulus. This means that the well is producing while being drilled. The return fluid from the well is diverted by a rotating control head to the surface separation equipment. The control head seals around the drill pipe while allowing the pipe to move in and out of the well and rotate. In some cases, a snubbing unit needs to be installed to allow movement of the drill pipe in and out of the well under pressure. Moving slips on the snubbing unit grip the pipe and push or pull it against the upward force in a controlled manner. Flow from the well is controlled via a choke manifold and then processed in a 4-phase separation system. This system separates the returns into its constituents: light fluid, crude oil, nitrogen and natural gas, and rock cuttings. The separated cuttings are collected for disposal. The separated hydrocarbons are sent on to production facilities or flared. The light fluid is pumped back to the rig's mud system for treatment and reuse. This completes the tour of the main surface systems that are used in 2-phase underbalanced drilling operations. In summary, underbalanced drilling allows the well to produce during the drilling phase. Underbalanced operations require additional surface equipment and a careful upfront design. When applied in appropriate wells, underbalanced drilling prevents formation damage, reduces drilling problems, and increases reservoir knowledge.